Hello everyone. In this video, we will look at the interface segregation principle. This is one among the solid decision principles. I took some time for this one because I couldn't find a convincing real world example. At last, I found one. Let's move forward. So, what is interface segregation principle? It states clients should not be forced to depend on methods, interfaces that they do not use. Here, important point is the perspective. We are talking about the perspective of the client. When we design something, there are two perspectives. One is the designer's perspective, which is the internal view, and the other is the user or client's perspective, which is the external view. Depending on your perspective, you may expect different things from the system. Let's look at two real world examples. One where we design based on the internal view, and the other where we design based on the external views. Imagine you are asked to develop a system for issuing passports, and you, being the designer, look at the system from your point of view and see everyone as a passport applicant. This is more the internal view. So you are the passport officer, and there are people who are coming to apply for passports. You create one application form for all. Everyone should fill this application form and submit that to the passport office. Let's look at the sample application. You can see the applicant should carefully go through the application and fill only the relevant sections. For example, if you are a minor or a kid, then you should fill in your parents' passport info and you need not give the biometrics. If you are a senior citizen, then you can skip the police verification and you can ask the passport to be sent via post. If you are a government servant, then you provide your service location and you also need to provide your permanent address, things like this. So when somebody starts to fill in, they have to really think through what are all the relevant things and they have to fill in only the relevant sections. It would have been easy if there are four different applications, one for kids, one for the elderly senior citizens, one for the regular ones, and one for the government servants. And the application asks only the relevant questions. This is what we mean by interface segregation principle. Let's look at another example. Here you are asked to design a system for the bank teller. This time the designer looks from the client's view and designs the system. You see people who want to deposit cash, people who want to withdraw cash, people who want to get a banker's check, people who want to exchange cash. All of them interact with the teller. Now, even though the bank teller must fulfill all the requests, for each group you create a separate form. For example, for the depositor, you have a deposit slip. For the withdrawal person, there is a check. For the banker's check, then there is a banker's check application. For cash change, there's a cash change application. And each client fills in the relevant information and views the bank teller serving only his request. This is very important principle for every designer. You segregated the interface based on the client that are going to use your system. Your system success depends on the ease of use for your clients. So now let's look at the software version of the same. Let's see the structure first. So basically here I have implemented both the bank and also the passport use case that I mentioned before. And I have a sample program just to see how the client will use the implementation that we are doing currently. Let's look into the code detail. Let's look at the passport officer class. If you look at the passport officer class, you can see the passport officer has a name and some constructor, and then we have three methods. Basically, it says you can apply for passport, submit biometrics, and then collect acknowledgement. And when you look at, for example, the passport application form, it's similar to what I explained before. So there's a name, date of birth, place of birth, postal address is minor, parent passport info, biometric required is senior citizen. Pretty much all the information is clubbed together in one class here. So depending on the use case, the client has to really set some things up and then ignore some things. Let's see how this is being used in the program. So here, if you look at the passport case, for example, we are going to apply for a kid's passport. So I say name is Khan, and then I give the date of birth. I say is minor is true. Then okay, I'm a kid, so I say parent passport is some information I provide. Then biometric required, I say false because kids we don't give biometrics initially, and then government servant we say false. Then we say senior citizen is false. Then you don't know whether, for example, police verification is needed or not. Then postal address you provide, service location. So you often get confused what to set, what not to set, and how what is a valid passport application form. This creates a lot of confusion for the user. Maybe there is some trial and error required, or you should provide some extensive documentation regarding how this class has to be used by the client. And also, when it comes to the passport officer class, for example, since we are doing a kids passport, biometric submission is not required. So you can see here we have set that to false. So just apply and collect acknowledgement is fine. But if you try to do this, maybe the implementation may throw error, or it may not do something, or it can make a log or something. So you can clearly see this interface is completely mixed up for all the clients together, which can create a lot of hardship for the users. Now let's look at the bank teller case. Let's assume if you see the bank teller also has pretty much all the implementation. So it has a name, has a constructor, then deposit, withdraw, exchange cash, and then get banker's check. So these are all the implementation. But then if you see for each of these case, we also segregate the interface. So we have a deposit teller, withdrawal teller, exchange cash teller, and a banker's check teller. And if you take any one, let us take for example deposit teller. So the deposit teller has one form which just takes the date of deposit, the account where you are doing the deposit, and the amount. And then it has only one method called deposit, which takes a deposit form. Now, if you look at the exchange cash teller, then exchange cash teller just takes the date, and since this is no account is needed, there's no account information. Basically, you just tell the amount, and then you can exchange the cash and then get your cash back actually. And withdrawal teller, if you see, it says what's the date, what's the bearer name, what's the account ID, and then what's the amount. And if you give the form, then you can withdraw. Now, if you see, for example, the usage for this system, let me go up. For example, we create a bank teller, but then when somebody wants to use, for example, the deposit function, you can treat the teller as a deposit teller. And then basically what you do, you say deposit clerk dot deposit and then give the deposit form. And the same teller, for example, when you want to do withdraw, again you treat him as a withdrawal teller, and then you just create this withdrawal form and then you do withdrawal. So this is like very straightforward. The client is bothering only about the implementation that is relevant for his use case, and also there is less chance of error and confusion and what's say documentation effort. So this is what we call interface segregation principle. This is one of the important ones in the object-oriented analysis and design. So the main thing is you should look your implementation from the perspective of the client and think what they would expect. And if something looks to be confusing or something looks to be out of place, then you have to really segregate them and then make things simple for them. Thanks for the attention. See you in some other video.